So many financial function problems have the following structure. There are basically four things going on. Four things vary: the size of the loan, the number of periods in the loan or the length of the loan, the monthly payment, and the monthly rate. We assume the periods are months. So a lot of situations you're given three of these four unknowns and you want to figure out the fourth. Now, a way to do this that's fairly straightforward will involve goal seek, which we'll get to in some later videos. But for now, there are two nice Excel functions we can use to solve these problems. One's called the rate function, and if you give me these three, I can figure out what the per period rate is. And the other is called the NPER function, like NPR, but with an E in it. Okay, and basically, if you're given everything but the length of the loan, you can figure that out. So let's try the following problem. You're borrowing $80,000, so that's the size of the loan. There are 120 monthly payments, that's the length of the loan. And the payment is $1,000 per month. What's the maximum rate you can handle? So you use this thing called the rate function. So you go to the function wizard and you just fill it in. So you go financial, you type in rate. Okay, so what do we know? Okay, we know there's 120 periods. We know the payment here, okay, was 1,000. There's the size of the loan is 80,000. Future value, there's nothing going on at the end of the loan. And let's assume it's end of the month payments. And so your rate per month is, okay, we need to see a few more decimal points there. Your rate per month is 0.724%. Okay. Now suppose you could pay $10,000 at the end. You're going to pay $10,000 at the end of that loan, so you're really not borrowing the full $80,000 in that sense. Then what would the rate be? Well, we could do function wizard. We could do most recently used. We can do the rate function. So the number of periods is still 120. Okay. The payment each period was $1,000. The present value was 80,000. Now the trick here is that future value is minus 10,000 because you're paying it in. So you can handle a higher rate because you're paying money at the end. Okay, so the applied rate would have to be higher to make this work out. Again, let's change that format. If I do home, format painter, and I can just change the format to right there, like that. And if I double clicking the format painter means it stays on until I hit the escape key. So I can handle it 0.818% interest. And as a check, if you use the PV function at the original to the first problem, present value of that monthly rate, 120 months of a payment of minus 1,000, you get $80,000. So that does work out. Now, how about the NPER function, the number of periods function? Okay, so in this situation, this is the one we don't know. So we know the other three. And we want to find the length of the loan. Now, Excel will have to approximate by interpolating number of periods. So suppose you borrow 100,000 at 8% annual payments of 10,000 a year. So we have the monthly rate. The monthly payment is the annual payment is 10,000. Size of the loan is 100,000. Okay, and again, you put in a positive sign for the size of the loan because you're getting that money up front. A negative sign for the payment, monthly payment, and at the end of the loan, if you're paying money, it's a negative sign. So how many years will it take you to pay this off? You're borrowing 100,000 8%, and you could afford to pay $10,000 a year. Okay, so this will be the NPER function, number of periods. So I come down here and type NPER. So the rate is 8%. Okay, the payments are $10,000 a year. I borrowed 100,000. There's no future value. Hopefully there's a future. And I put end of the year payments there. And it's 20.91 years. So what that means is 20 years would not be enough to pay off the loan. 21 would basically, at 10,000 a year, would overpay the loan. And basically, if you interpolate like the present value of 100,000, paying 10,000 a year for 20 years, paying for 21 years, you could figure out sort of 9/10 of the way between 20 and 21 years that loan would be paid off. Okay, so you can check here. Present value of paying 10,000 a year for 20 years at 8% is 98,000. 21 years is a little bit over 100,000. And it figure out if you take 91% basically of the amount you're going over here and 9% of the amount you're going under the 100,000 here, then you get it to come out to 100,000. Now suppose we pay 40,000 at the end of the problem, okay? Then how many years would it take to pay off the loan? Well, it certainly can't take over 20 years because we're paying a big chunk at the end. So again, we would use that NPER function. I can go to most recent. And so just fill in the blanks. So you know the rate is 8% per period. The payment is 10,000 a year. The present value, excuse me, the loan is 100,000 today. We're going to pay 40,000 at the end there, and it's end of the year payments. So 15.9 years would take care of it. So 15 years won't pay it off, but 16 years will. So these functions are very useful. There's a sort of more general way to do this without functions using the goal sheet capability of Excel, and we'll get to that in a later set of videos.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.